Hi everyone, and welcome to Module 1. What is Artificial Intelligence? My name is Mihika Singh, and I will be guiding you through this course on Introduction to Artificial Intelligence with Machine Learning. Before we start, I just want to set expectations for what this particular module is going to be. The goal here is to actually understand what AI is, how it works, and why it matters. By the end of this module, you should be able to clearly explain what artificial intelligence is, how it differs from traditional programming, and why it has become such a big part of our world today. So, let's start with something very important. When most people hear the term artificial intelligence, they immediately think of something futuristic, like robots, sci fi movies, and some advanced technology that's still 20 years away. But the reality is very different. AI is not something that's coming in the future or that just spawned 2 years ago. It is already deeply integrated into your daily life and it has been for quite a long time. Every time you unlock your phone using face recognition, that's AI. When Netflix suggests a movie you might like, that's AI. When your email filters out spam automatically, that's AI. Even something as simple as Google Maps predicting traffic is powered by AI. What's interesting is that most of this AI is invisible. It's not something you actively see, it works quietly in the background, shaping your experience without you even noticing it. So instead of thinking of AI as some futuristic concept, it's more accurate to think of it as infrastructure, something that is already influencing what you see, what you interact with, and even what decisions you make. So, now that we understand that AI is already around us, the next step is to actually define it properly. Artificial intelligence is essentially about building systems that can perform tasks that would normally require human intelligence. This includes things like reasoning, problem solving, understanding language, recognizing patterns, and especially learning from experience. One really important thing to understand here is that AI is defined by what it does, not what it looks like. A lot of people associate AI with robots, but in reality, most AI systems are just software running in the background. If a system can take input, process it, and make decisions in order to achieve a goal, then it can be considered as an AI system. So, AI is less about machines that look like humans and more about systems that behave intelligently. Now, to really understand why AI is so powerful today, we need to understand what changed compared to traditional computing. In traditional programming or computing, everything is based on rules. A developer writes explicit instructions. For example, if this happens, then do that. The if then logic, right? This works well for simple problems, but it completely breaks down when things get complex. Imagine trying to write a set of rules to recognize a human face. You would need rules for lighting, angles, expressions, and so many other variables. It becomes almost impossible. This is where AI introduces a major shift. Instead of writing rules, we give the system data and a goal. The system then learns patterns from that data. So instead of telling the computer how to do something, we show it examples and it figures out the pattern itself. The shift from rule based systems to data driven systems is what makes modern AI possible. And a really good example of this shift is spam filtering. In the early days, spam filters were rule based. Developers would create lists of words like free or credit card and block emails containing those words. And for obvious reasons, that didn't work for long. Spammers quickly adapted. They changed spellings, added symbols, and found ways around the rules. So the system kept failing, and it required constant manual updates. Then came machine learning. Instead of relying on fixed rules, the system started learning patterns from data. It looked at thousands of emails that were marked as spam and learned what they had in common. So when new types of spam appeared, the system could still detect them without needing a human to update the rules. This is a perfect example of why learning based systems are much more effective in environments that are constantly changing. Now, let's clear something up: the difference between AI and machine learning. Artificial intelligence is the broader concept. It's the goal of creating systems that can behave intelligently. Machine learning, on the other hand, is the method we use to achieve that goal. It is a set of techniques that allows systems to learn from data instead of being explicitly programmed, as I mentioned earlier. A simple way to think about this is that AI is the car and machine learning is the engine that powers it. Most modern AI systems rely heavily on machine learning because it allows them to adapt, improve, and handle complexity without human intervention. So, whenever you see an AI system getting better and better over time, machine learning is usually what's making that possible. Now, memorization versus learning. This is where a lot of misconceptions come in. Many people think that if a system has access to more data, it automatically becomes smarter. But that's not true. Storing data is not the same as learning. Like, buying your textbooks is not the same as learning them, right? For example, if you download an entire database, like Wikipedia, for example, onto your computer, the computer now has a huge amount of information and very low storage as a result, but it hasn't actually learned anything. Learning only happens when the system uses that data to improve its performance on a task. The key idea here is generalization. A system should not just remember past data, it should be able to apply what it has learned to new situations. So, effective machine learning is not about memorizing data, it's about recognizing patterns and using those patterns to make better decisions. To make this idea more precise, we define learning using three components. First is the task. First is the task, what the system is trying to do. Second is the experience, the data or the examples it learns from. And third is the performance, how well it performs the task. A system is only considered to be learning if its performance improves as it gains more experience. So, learning is not just a vague concept, it's something that can, in fact, be measured and evaluated. This is important because it allows us to treat machine learning as a science rather than just an abstract idea. Now, an important question is, if AI has been around for a long time, why is it suddenly growing fast so now? There are four main reasons. First is data. Today, we generate massive amounts of data from apps, social media, and online activity. Second is hardware. Modern processors like GPUs allow us to process large amounts of data very quickly. Third is better algorithms. The methods used to train AI systems have improved significantly over time. And lastly, real world demand. Businesses and industries now rely on AI more than ever to solve complex problems at scale. All of these factors together have created the perfect conditions for AI to grow rapidly. Now, modern AI systems have also become much more advanced in terms of what they can process. Earlier systems only included one type of input, like text, but now AI can handle multiple types of data at the same time: text, images, audio, documents, and even code. This is known as multimodal data, multiple modes. It allows systems to perform much more complex tasks, like analyzing documents, interpreting visuals, and generating responses all within a single system. This is one of the major advancements that has made modern AI so powerful. One of the most important things to understand about AI is that it is often invisible. It works behind the scenes in many high impact applications. For example, it is used in medical imaging to detect patterns that might not be visible to humans. It is used in document summarization to process large amounts of information quickly. And it is used in recommendation systems to personalize your experience. Even though we may not always see it, AI is influencing decisions and processes across many industries. There are also several misconceptions about AI that are important to address. One common idea is that AI is something magical or conscious, but in reality, AI is built on math, data, and algorithms. It does not think or feel, it simply processes patterns based on the data it has been trained on. Another important point is that AI is only as good as its data. If the data is biased or incomplete, the results will also be biased. So, understanding these limitations is just as important as understanding what AI can do. Now, to summarize everything we've covered in this module, artificial intelligence is about building systems that can perform tasks requiring human like intelligence. Machine learning is the key method that allows these systems to learn from data. And learning is defined as a measurable improvement over time based on experience. In the next module, we're going to go deeper into how machines learn. We'll look at models, training, evaluation, and how systems improve their predictions step by step. So now that we understand what AI is, we're ready to understand how it actually works. I am very excited to be conducting this course as the Leadership and Innovation Ambassador at the Innovation Hub. If you are someone who is interested in STEM and willing to learn, create, and collaborate with like minded peers, we will be happy to welcome you into the community. Join us to make a real difference. Thank you so much for your time, and I am excited to see you in the next module.